Yeah, thanks for the introduction. Welcome to my session. I think you have already mentioned everything about me. The only thing maybe I just recently moved to Australia. So I'm based in Perth right now, but I'm still working as a freelance software architect for Swiss companies. So today I want to tell you something about a project I was working on last year. The project is called Autonomous Ropeway System. I just want to give you an introduction of the project, then what challenges we faced, and how we used various Azure services, especially Azure Arc, to solve these problems. And then I want to give you a bit more in-depth about the features of Azure Arc. Before we start, a ropeway system, what is that? Here you can see a classical ropeway system in Switzerland. There we have them literally everywhere, in summer for hiking, in winter for skiing. And what you can see here, this red box is also called a vehicle, and it brings people up the mountain. Usually you step in the valley and just go up the mountain and get out. It's quite simple. And my customer had the idea to automate this whole system. So the idea is that they need almost no personnel to operate it. One of these tasks would be for the vehicles to come out of the garage when they're needed. Right now, the workflow is that the employees have to estimate how many people will come during the day and put the vehicles from the garage on the ropeway in the morning, and on the evening put them back in the garage. So it's quite a lot of work for them, and it's also not flexible at all. For example, if it's a bad weather in the morning, not many people will come, but if the weather is fine in the afternoon, more and more people will come on the afternoon, and so they maybe don't have enough vehicles, people have to wait, and yeah, it's not practical for the customers. And since the vehicles are coming out of the garage, they are only used when they're needed. This has many advantages cost-wise. For example, there's less wear and tear, less energy usage, and overall cheaper to run. Another advantage, if it's autonomous, you can run 24/7 and you don't need people overseeing it, or at least less people. And another nice feature is that if you have a smart system, you can implement routing through a system or through the network. For example, right now, you just go from point A to point B. But with this smart system, every vehicle can find its way through a network. So for example, like a subway, you can say, I'm at point A, I want to go to point D, and the system routes me there. For our test project, we had 2 mountains where we wanted to go to, and the customers could choose in the valley if they want to go to mountain A or B, and they got redirected there without having to do any switches of transportation. The initial challenges we were facing, the first one was more a challenge for me because I'm a cloud architect. I'm used to use cloud services, just click through the Azure portal, use whatever I need. But in this project, we had to use existing hardware. This means we had to install the software there, find on-premise software, and yeah, just rely on the software we manage ourselves. And the second, probably bigger problem was that our customer was controlling the firewall and it didn't allow any inbound traffic. So some problems we faced was we didn't know how to do the deployments. For example, from Azure DevOps, you need a connection to your on-premise infrastructure to push the deployments. This was not possible. Also, we couldn't use any cloud service like Azure Monitor to gather logs, create dashboards, create alerts. And so my first idea was we could use a VPN connection to Azure or an express route connection. Express route is a private connection, so your ISP has to create this, and it's a direct connection from your on-premise data center or location to Azure. It's not a connection over the internet. But the customer immediately said, no, we don't know this, we don't want it. So we had to find a solution to work around this. And here you can see a simplified version of the network. So what they had is a whole bunch of Ubuntu VMs and and here we were running Kubernetes. And the only thing that worked was from the VM, go through the firewall to a container registry and download new container for our Kubernetes cluster. But everything else was blocked. For example, as said, the connection from Azure DevOps was blocked. So we had to find a solution how to implement a modern process to have deployments, monitoring, and so on with all these limitations. And here you can see our test station. So the manufacturer of the Rope system built one of the stations in their manufacturing facility. And there we could test our software with the real system. For me, this was quite cool because I used to work on online shops and they are not really exciting. Like you click on buttons, you buy a couple clothes and that's it. And with this system, if you click on a button, suddenly a door opens or a vehicle starts moving. So this was quite interesting to see how the whole system works. And here you can see how the system works from a customer perspective. So the customer enters the area and they have here this board, and there they can select where they want to go. You might notice from elevator in airports or shopping malls where you select on which floor you want to go, and then you get a message, go to elevator A or B, and then the elevator brings you there. And that's the same way. So you click where you want to go, and then you have here a board, and it tells you where this vehicle is going, how long it's going to take to arrive there, and how many people can fit in the vehicle. So I can see it will take 15 minutes to get there, and still 10 people can fit in there. And due to all the limitations, I discovered Azure Arc, and I thought this might be something useful, and so we built a proof of concept around Azure Arc. So what is Azure Arc? It's a way to project your infrastructure that's running outside of Azure into Azure. So outside of Azure means it could be on-premise or with a different cloud provider. So it could be Amazon, Google, whatever. And you can manage Linux and Windows VMs and bare metal server. Any Kubernetes cluster, as long as they're CNCF, Cloud Native Computing Foundation certified. And you can also manage SQL Server. And here we have the Azure portal. And here on the left side, you can see what you can manage. So it's a whole bunch of services. Some are still in preview because there are a lot of new features, a lot of changes going on. And it helps you to manage your on-premise or outside of Azure infrastructure the same way as you would do if it's running on Azure. So this means, let's say I have a couple on-premise VMs and a couple Azure VMs. Usually I have to run several like tools to manage them. Like I have my cloud tools and I have my on-premise tools. And with Azure Arc, you can manage them all with your cloud tools. So I can use the Azure Update Management or Configuration Management or install the Microsoft Cloud Defender. So as an administrator, I don't have to learn several tools. I use the cloud tool and manage everything with the same tools. And for us, since we had a Kubernetes cluster, there's something called Azure Arc enabled Kubernetes. And with this, you can manage a Kubernetes cluster. The way you manage this is through extensions. So once you have Azure Arc installed on your Kubernetes cluster, you can install extensions, for example, for Azure Monitor or for Azure Policy, and then you can use Azure functionality on your on-premise Kubernetes cluster. And another big advantage is that you can connect to your Kubernetes cluster through Azure Arc without opening any incoming ports. So the way it works is the Azure Arc agent is running inside the Kubernetes cluster and creates an outbound connection to Azure. And I, as a developer, can connect to Azure, and through this connection, can access the Kubernetes cluster as if it was in my network. So then the next problem we had was the deployment. How to do the deployment without any access to the Kubernetes cluster. And for this, Azure Arc has an extension agent on the Kubernetes cluster. For GitOps, there are two big projects. One is Argo CD and the other one is Flux. Azure uses the Flux agent, and this agent runs inside the Kubernetes cluster. And you configure this agent to poll a Git repository. And if there are any changes in this Git repository, the agent downloads these changes and installs them. And the Git repository can contain YAML files or Helm charts. And it doesn't matter if it's a private Git repository or a private one. So I'm going to show you how we did it with a private repository. And again, you don't need an inbound connection inside your Kubernetes cluster because the agent is running in the cluster and pulls the changes. So all you need is a connection, an outbound connection over port 443, HTTPS. And the way we managed the deployment was we had two Git repositories. The first one was the normal application repository where we had our pull requests, we had build pipelines, we built the Docker image, ran our tests, and pushed the image to the registry. And then we had a second repository where we had the configuration. So this configuration more or less contained the Helm chart. And this Helm chart told the Kubernetes cluster what container to install or to run inside the cluster. What's nice about this, with Flux, you can also create dependencies or configure dependencies. For example, if I have a new application, I want to first create a new namespace inside my Kubernetes cluster and then deploy my application there. If I try to deploy the application first, the application will say, I can't find the namespace and it won't work. And with Flux, I can configure the dependencies. And here you can see what I just said. So on the left side, we have the normal application repository. So here, so the developer just implement the features, create a pull request. Then we have a pull request pipeline running unit tests, verifying everything is working. Then we have a CI pipeline. The CI pipeline may run more tests and create the Docker image and push it to an Azure Container Registry or any other container registry. And then you have a CD pipeline. This can be automated or manually triggered. Since our Rope system was transporting people, there are quite some strict laws about it in Switzerland. So there's an official government body that has to verify everything is running and certified. So we couldn't deploy all our changes. So we had to do it manually, get certified, and then just run it. And what this CD pipeline does is it makes changes in the configuration repository. So in our case, we just changed the tag. So we updated the tag, committed this change. And since there were changes, the GitOps agent inside the Kubernetes cluster saw that there are changes, downloaded them, and applied them to the Kubernetes cluster. And with this approach, we were able to do automated deployments without having any access to the Kubernetes cluster. So since I was contracted to also do some work, show something and not just talk, I was tasked to make a proof of concept. And the idea was to make it as realistic as possible but also as simple as possible. And since I said I'm not used to run software on premise, I didn't want to go with a full Kubernetes version, so I tried K3s because it's lightweight, it's open source, CNCF certified, so it's everything you want, and it's also developer rancher. So there's a big company behind it and also a big community, great documentation. And the best thing about is you just need this one line command and you have Kubernetes running on your Ubuntu VMs. So it just took us a couple minutes to get started with our Kubernetes cluster. And the next step was to install Azure Arc. So to install Azure Arc, you have to have the Azure CLI on your master node installed, and also the Azure Arc CLI extension. You can install this extension again with a one-line command. So it's quite easy to get started. And then you have to register a couple Azure provider. For the one of you who don't know Azure provider, they are a little bit like NuGet packages in .NET. Like they provide services and you can install them or activate them if you need them. Once you have installed them in your subscription, they are there for all your services. And in Azure, you can register them with a single line command. And what we needed was just the Kubernetes. And once this was installed, we could run Azure Arc on our Kubernetes cluster. So as you can see here, we can check, for example, here for the provider Microsoft.Kubernetes, we can see it's registered. So once you register, it takes around 10 minutes. And once you get the registration state registered, you're good to go to install Azure Arc. And installing Azure Arc is, again, just a one-line command. So it's very easy to get going. All you need is the Azure CLI command. Then you provide the name of your Azure Arc instance and in what resource group it should be installed in your Azure subscription. Then, depending on the internet connection, it takes 5 to 10 minutes. And after this, you can check with the CLI that it's installed, or you can also check in the Azure portal. And what this command does is it uses Helm charts to deploy the Azure Arc applications inside the Azure Arc namespace. And if you look into this Azure Arc namespace, there you can see I think it's 10 applications that are running there. And if you look at the name, you can already guess what these applications are doing. For example, you have here an extension manager taking care of your extensions. Then you have here a matrix agent taking care of your metrics or like gathering your metrics. And then you have here an Azure Active Directory proxy, which allows you to connect through Azure Active Directory to the Kubernetes cluster. And as I said before, you also have it in the Azure portal. There it's a so-called single pane of glass, because you have one dashboard where you can see and manage everything. So you don't have to go to different tools, different views. It's just in one place, and you can manage your outside infrastructure against means another cloud provider or on-premise, the same way as you do your Azure infrastructure. And if you go back in the Azure portal to Azure Arc instance, we can see everything we can manage on the left side. And if you click here on our Kubernetes clusters, we can see that currently we are managing 2 Azure Arc Kubernetes cluster. And on this overview, you already get some very basic information. For example, in what resource group it's running, what the Kubernetes version that's installed on the cluster, and in what location it is. And if you want more information, you can click on it. For example, on the K3s Arc. And then you get the overview, which looks very familiar as the Azure Kubernetes service. So if you're used to AKS, it looks more or less the same. So on the top, you have a couple basic information like logging or access control. And in the middle, you can see what's going on in the Kubernetes cluster. The only difference to AKS is if you click, for example, here namespaces, you don't see your namespaces right away. You have to first log in with an access token. That's just an additional layer of security. And to get this access, you can use the Kubernetes RBAC, the role-based access control system, or you can use the Azure RBAC. And as I said before, for the proof of concept, we wanted to make it as simple as possible. And so we decided to go with the Kubernetes RBAC system, because for Azure RBAC, you have to do some Azure Active Directory app registration. You need an administrator doing this for you, and it's more complicated. And yeah, since we said we use the Kubernetes RBAC, we could create a user inside the Kubernetes cluster, give this user the permissions we needed, and then generate an access token with this user. And then we can use this access token to connect in the Azure portal to our Kubernetes cluster. But as a developer, I can also create a proxy connection. So I can use my Windows development machine, and I create this proxy connection through Azure Arc to the Kubernetes cluster. This downloads the Kubernetes configuration, and then I can access the cluster the same way as I would access a local cluster or an AKS cluster. And the way you create this user in Kubernetes, CLI, which always starts with kubectl, then what you want to do, in this case, I create, then on what object you want to do the work. So that's a service account, that's a user in Kubernetes, and then you give it a name. In this case, I just want to have a user that can do everything, so I named it admin user. Then you have to give this user the desired role. In Kubernetes, you can use a cluster role binding. Then you say what cluster role. So I use the cluster admin, so my user can do everything on the cluster. And lastly, you say what user. So it's the previously created admin user. And once you have this in place, you can create the access token, again with the Kubernetes CLI. And so again, you say create token, and then you say for what user you want to do it. So for the admin user, and this pastes the bearer token, or prints the bearer token in the command line, and then you can copy this token and sign into the Azure portal. So once you signed in, you have access to your on-premise Kubernetes cluster through the Azure portal, and you can see what's going on there, and can even delete pods or like analyze what's going on. So as I said before, Azure Arc allows you to manage or bring Azure services to your Kubernetes cluster through extensions. And the most important one was the GitOps extension for us for the deployments, but there are also more useful ones. For example, Azure Monitor, which allows you to use Azure Monitor to create dashboards, what's going on inside your cluster, or create alerts. And another one is, for example, the Azure Key Vault. So you can use your Azure Key Vault as your secret store. So what this extension does is it redirects the request for secret from the Kubernetes cluster to Azure Key Vault. So you can safely or securely manage your secrets. But since this talk is called DevOps in Kubernetes, let's focus on the GitOps extension. The GitOps extension, as I said before, is a Flux operator, and it can be installed via the Azure portal or via the Azure CLI. I'm going to show you later how it did with Azure. Yeah.
Yeah, sorry to cut you off. Would you mind spending a minute elaborating on GitOps? What is GitOps?
Yeah, I'm going to show it in 2 slides again, what it is and how it works.
We can wait. Thank you.
Okay. Just a second about Flux and the GitOps extension. There are 2 versions. So our demo used version 1 because last year there was only version 1 available, and version 2 has more features. For example, you can configure dependencies, but it lacks some functionality, and it has a horrendous documentation. Like, I've never seen such a bad documentation, and the functionality doesn't reflect the documentation at all. So for now, I'm going with version 1. And to your question, how GitOps works, the idea of GitOps is that you have a GitOps operator running inside your Kubernetes cluster. This is in our case here, the Flux operator, but it could also be something else. Another popular one is Argo CD. And what this Flux operator does is it checks a Git repository if there are any changes. So it is configured to look in this GitOps repository if there are any changes. And if there are changes committed, the Flux and also applies them. So for example, if I have here in the GitOps repository a Helm chart that says run version 1.0 of my container image, the Flux operator downloads it and runs the Helm chart. And so I have the version 1.0 running inside my Kubernetes cluster. And now the developers create more features, implement them, and then I decide it's time to update. So I change the configuration inside the GitOps repository and say, I want to tag 1.1 of my container image. I commit this, and then the Flux operator sees there's a new commit, downloads it, and sees that I want to run the tag 1.1 and starts or downloads the container image with the tag 1.1 and starts it inside the Kubernetes cluster. And therefore, I have the new version running inside the cluster without actually having to push any changes inside the cluster. I hope this answers the question.
Yeah, Wolfgang, this I guess is a good description of exactly what it's doing. I'm not sure the term is as common as it flows off your tongue. So maybe like a conceptual description, like what are we trying to accomplish with GitOps might help the audience. That was where my head was.
Oh, okay. Yeah, usually, or in the past, you have a CD pipeline, for example, in Azure DevOps, and then you push your changes. This could be to an Azure service, to a Kubernetes cluster, to your IaaS on-premise, but it was always a push. And with GitOps, you have a pull. So the GitOps operator pulls changes or pulls new features. So I think that's the biggest difference between these 2 approaches.
Thank you.
Okay, if there are any more questions, just ask. If not, I'm going to continue. I said before, you can install extensions through the Azure portal or the Azure CLI. My preferred way is the Azure CLI because it's very simple and you can easily repeat it and copy the code. So if you look at the command, even if you don't know Azure or the Azure CLI, you will understand what's happening. So again, with the Azure CLI, it always starts with the AC and on what object you want to do something, and then what operation you want to do. So on the Kubernetes configuration, I want to do a create. And then you have parameter, and the parameter are named so you already know what's going on. So you provide a name, the name of your cluster, the resource group, and here the repository. So what you can see is here I'm using a DevOps repository. So that's a private repository. So I'm going to show you in the next steps how to access the private repository. And then you can also configure the operator here. For example, with here changes. Usually you have between 5 and 30 minutes in a production environment, but for our demo, I don't want to wait, so I put it in 1 minute. Then you can also say on what branch. So only check the master branch. This means the developers could work on their development branch or feature branch. It doesn't affect deployment. Only if I commit to the master branch, it gets deployed. And lastly, I also configured Helm. So I can use Helm charts for the deployment. And once it's installed, you just get a confirmation message with a big wall of text, which is not really helpful. So let's go into the Azure portal and see how it looks there. So we are back in our Azure Arc instance. And on the left side, if you scroll down a bit, you have here the tab for GitOps. And there you can see there's the GitOps extension, which we just installed. And if you click on this, you get more information, but you can see it's the same information we used before. For example, here the git poll interval is 1 minute. It's here the same name. And what's also interesting is on the bottom here, it creates a public SSH key. So we're going to need this for the authentication. So I copied this SSH key. And before I go to Azure DevOps, I want to show you the log messages it generates. Again, it's a wall of text. It's sometimes useful. Most of the time, it's not. For example, here you could see it also prints the same SSH key, but everything else is kind of hard to figure out what's going on. So since I know I have a private repository and the GitOps has to authenticate to access it, I copied the SSH key. I go to Azure DevOps and add the public SSH key. In GitHub, for example, or GitLab, it's the same. You just go to user profile, you have SSH keys and paste it in there. And once you pasted it, the GitOps agent has access to the private repository and can download the changes. So when I was creating the demo, I forgot to create a namespace. And so I got a message, an error message here. And here it says, namespace demo not found. So in this case, the error message was helpful. And I created the demo namespace. And after I created it, the GitOps agent automatically deployed my application. And now I have a pod and a service running in my Kubernetes cluster. And you can see I also have a public IP address. And if I go to this IP address, I can see my Swagger UI running and I can test the application. Then I said before, we use 2 Git repositories, one for the application and the other one for the GitOps configuration. And the most important file is a YAML file, which describes where the Helm chart is, in what branch it should look for, what path, what Git repository. You can see the file. You have here the Git repository of the Helm chart, what branch and the path. And the second folder inside this Git repository is the Helm chart itself. So I can show you this in a couple slides in the demo, so you can see how the repository actually looks like. And then we have a CD pipeline for this GitOps repository. And what this pipeline does is it's reading the newest tag from the Azure Container Registry, and it replaces the tag in the values YAML file. That's part of the Helm chart. And then it commits the changes. And with this approach, we can always have the newest version deployed on the cluster. And since we made any changes, the GitOps agent sees that and pulls the changes inside the cluster and applies them to Kubernetes. And another nice feature of Azure DevOps is that when you start a pipeline, you can pass parameter. So our developers wanted to pass a parameter for the version they want to run. So they can either run the latest version or they can set a specific version, which was quite useful for testing. As I said, for a compliance reason, we had to be quite strict with testing. And so we could make sure that we test exactly what we want. Then my experiences with the different versions. Version 1 is deprecated. So when you install it, you will get a notification that it will be removed in the future. As you've seen, it's very easy to use, and it can deploy YAML files or Helm charts. So everything you need with Kubernetes. Then the version 2 has additional features. For example, it uses Customize to configure the application. You can configure dependencies. But when I tried it, I had no luck deploying Helm charts. It didn't work, although the documentation said it works. I did exactly the same steps, and it didn't make any sense. So it was my worst Azure experience so far. Okay, and now after all the talking, I want to show you how this actually works. So if I go to my Azure DevOps, I have here two pipelines. The CI pipeline, which just builds the application, builds the Docker container, runs unit tests, and then a CD pipeline, which updates the Git repository. And before I do endpoint here, and it says hello all day DevOps 2022, because that's the last conference I talked at, and I haven't updated it since. So it's time to update this, and that's what we're going to do together now. So if I go to my code, obviously usually you would do this in an IDE like Visual Studio, create a merge pull request, and so on. But since this would take too long, I'm just going to edit it quickly here in the browser. So we say, hello Boston, hello Azure Boston. We commit this. Just keep it very simple. And what this does, it automatically triggers the CI pipeline. And we can take a look at the CI pipeline. It's nothing special. What it does is it calculates the Git version. So I create a new version. Then it runs a build on the Docker container. The Docker container or the Docker file has a build of my application and also runs my unit tests. Then the next step is here, I search for the test results inside the container and copy them outside of the container so Azure DevOps can access them. Then I publish the test results so I can see them after the pipeline is finished. I also publish the code coverage, and then I push the Docker image to my container registry. So this it's going to take around 1.5 minutes. So are there any questions at the moment while we wait for this to finish?
So if folks want to ask a question on your own, feel free to unmute and pipe in. While I have the floor here, I'll pop my question, which is, when you do these upgrades in this manner, is it possible to do them without downtime?
Yeah, exactly. That's a Kubernetes feature. And the way Kubernetes works is you can have two different versions of the deployment. The default one is called a rolling deployment. So what Kubernetes does is it, let's say you have 10 pods of your application, and then Kubernetes starts one new one and then deletes one old one. And then again, one new one and deletes one old one until it gradually replaces all old ones. This has the advantage that you always have around the same amount of pods running, but you have to make sure that your application can handle two different versions. This is especially a problem if you have a database. For example, if you delete a column in your database and then deploy it, your old version will break probably. So you have to plan the deployment a bit. The second mode is called green-blue deployment. And what Kubernetes does here is it starts all new pods. For example, if our application has 10 pods, it starts 10 new ones and then redirects all users to the new ones and then deletes the old ones. So in this case, you don't have to handle two different versions, but you have the double amount of pods running at a time. So you need more resources.
Thank you.
And I can also show you, I have to quickly log into the terminal, and then I can show you how the deployment works. So we will see that a new pod is started, and after it started, the old one gets deleted. So here you can see that currently we have one pod running, and it's running for 35 hours. So now we're going to deploy our new version, and what we will see is that a new pod will be started, and once it's running, the old pod will be deleted. So first, let's start the pipeline for the new version. So what I say is run pipeline, and here I can see I can pass a parameter to my pipeline. If it's 3 times 0, I use the newest tag from the Azure Container Registry, but I can also use a specific version. So in this case, I want the newest version and run this. And we can also take a look at this pipeline. For this pipeline, I use a couple templates just to make the pipeline smaller. So what we can see here is the first template is configure Git. So what we do here is we configure the Git config. So we set a user and an email address, I think. Yeah, here the email. And because we're gonna commit changes to our branch, and so we're gonna have a user doing this change commit. The next step is we check out our branch. Then here we have the if. So if the parameter is set to 3 times 0, we go with the Azure CLI to the Azure Container Registry and read the newest tag and write it into the variable tag. Or if it's not equal to 3 times 0, then and the last step is we do a search and replace. So we use regex. We look for the tag inside the values YAML file and then replace it with the value we have in our tag variable. And lastly, we commit the changes. So that's what's happening right now. And here you can see that here's a new container being created. It's pending. And from here on, we have the container running. And as this container was running, the old container got terminated. So now we have our new version running inside the Kubernetes cluster without any downtime for the users. And if you go back to our API and we execute it again, we can see that we have here the new version or the new message we configured before. So the deployment worked, and I didn't have to have any access to the Kubernetes cluster. So the last thing I want to show you is the repository. So as I said, there are two parts in this repository. One is the YAML file that says where the Helm chart is located and what branch. And the second part is the Helm chart. In case, if you don't know Helm, Helm is a package manager, and it just helps you to take care or to manage all the files you need to deploy your application to Kubernetes. So inside this templates folder, I have all the files that my application needs. For example, I have the deployment. With Helm, you have this double bracelet. It looks terrible if you have never seen it before, but it's very easy once you're used to it. And you can pass variables, you can create loops, so it's very powerful compared to normal YAML. And the most interesting file is this values YAML file. And what this file does is it contains all your variables, and these variables are passed into the files. So as I said, I have here the tag, and what the pipeline did was it looked for this tag and replaced the value with the newest version. So if you look at the Git history, we can see we had the version .41, and now we have the version .42. And that's how we achieved the automated deployment. Okay, so we're almost running out of time. So let's go to the other useful extensions. When you have a system where people are using it, or especially sitting in it and being transported, security is very important, because you don't want to have a door open while they are somewhere high up or just two vehicles run into each other. So we looked into using Azure Key Vault as our secret store. The Azure Key Vault is managed by Microsoft. It allows me to configure who has access. I can create updates. I have audit logs. So everything I need to have my passwords, connection strings, and so on saved securely. On the other side, if you use Kubernetes and secrets in Kubernetes, they are not encrypted. They're just in plain text, and they're not very secure. So we wanted to use Azure Key Vault with our Kubernetes cluster. And with the Azure Key Vault extension, what this extension does, it redirects the request for a secret from the Kubernetes secret store to the Azure Key Vault. So the developers don't have to change anything in their application. It's all hidden away in Kubernetes. And with this, the developers don't have to change anything, but we have all the advantages and security from Azure Key Vault. And an approach how you can manage this would be to have another pipeline, and this pipeline writes secrets in the Azure Key Vault. So you always know what secrets you have, and you could also create, for example, automated updates that every week you write a new secret into the Azure Key Vault, and then the application grabs this new secret and uses it. And here you can see how this works. So we have here, in a very simplified way, we have here our application, or actually with here our application, and the application wants to access secrets, and the Azure extension redirects it to the Azure Key Vault and uses the Azure Key Vault as the secret store. So like here, our application doesn't have to change anything and also doesn't need to know anything what's behind going on. So it's very easy for the developers. Another important feature for probably all applications is monitoring. You want to know what's going on with your application, with your cluster, if you're running out of CPU, of hard disk, whatever. And in best case scenario, you get a notification when you see something is about to go wrong, and you can fix it before it goes wrong. And your customers don't even see that something went wrong. And there's again an extension in Azure Arc. It's the Azure Monitor extension. And what this does, it installs the Azure Monitor agent inside a Kubernetes cluster. And this agent gathers information about metrics, logs, and sends them to Azure. And this again, from inside the cluster outside, so you don't need an inbound connection to access the logs. And then you can use Azure Monitor as if you were using Azure services. In Azure Monitor, you can create dashboards, you can create alerts, you have container insights, so you can see exactly what's going on with every container. And it's very easy to use and very helpful. So here we can see in our Azure Arc instance, I've installed the extension, and now I can already see what's going on. Everything you can see here is out of the box. I didn't have to do anything. And what you can see here is at around 9:30, the CPU usage suddenly skyrocketed from around 10% to 75 and then over 80. And I also had an alert. So the support team got an alert message when it reached the 80%. And so they could react quickly, look into the problem and fix it. And you can see it never reached 100%. The service may have been a bit slower for the customer, but it always worked. And at 9:38, the problem was resolved and it was back to normal usage. And here we also have, like, what you can see here is on the node level. So it's on the machines itself. And here you can see what's happening inside the container. So you can see here, we have the customer API container. And on the right side, you can see the usage was very high. So there was something going wrong. So the support team fixed this problem. And afterwards, the usage was quite good again. So this was everything about our proof of concept. So you can say it was very successful, but we also wanted to look into the future. What are other options we can achieve with Azure Arc? And Azure Arc is probably the most powerful service of Azure. So there are so many more features. And in the last couple of minutes, I just want to show you some features that are also available and are quite interesting. Azure Arc is split in different categories. And the first category is the so-called Azure Arc enabled infrastructure. What this does is it allows you to manage your VMs, for example, or your hardware, more or less. So you can manage VMs, you can manage Kubernetes cluster, you can use Azure Stack HCI. That's a way to run Azure services on-premise. It's built on Windows Server 2022, but it's a bit like having your own Azure portal inside your data center. And then the more exciting services are the Azure Arc enabled services. And this feature allows you for the first time to run certain features outside of Azure. For example, you can run Azure App Services or Logic apps outside of Azure. So you can say, I want to have a website for my company. It's only internal, and I can use Azure App Service to run it inside my data center. So I don't have to care about setting up a web server, managing everything. I just use the app service. Microsoft takes care of it for me. And the probably most interesting features for the future are the Azure Arc enabled data services. This allows you to run Azure data services on your on-premise Kubernetes cluster. So for example, you can have Azure SQL managed instance or Postgre instance running inside your Kubernetes cluster. This means that you can use Azure managed services, but don't have to give your data to Azure. It always is inside your facility. And also you can do machine learning. Again, you could keep your data on-premise and just use Azure machine learning on it. You don't have to upload it to the cloud. All the services need a Kubernetes cluster. So you have to know the basics about Kubernetes. And as said before, you can bring these Azure services to your on-premise data center. And especially in the EU, we have quite strict laws about data protection, who can access your data. And there are some legal problems with cloud provider because they're American companies. So by law, they are allowed to access the data, but by EU law, they are not. So it can be quite complicated. But if you use these services, you have your data on-premise, and Microsoft never has access to them. So this could open the door for many companies that say, we want to use it, but our legal team doesn't allow us. And here you can see an overview of what's available. So you can see it's a very massive service. There's so many different features you can use. And the most important thing to remember is here at the bottom, you can use any infrastructure. So it can be on-premise, it can be VMware, it can be Amazon, Google, AliCloud, doesn't matter. Once you install Azure Arc, you can bring Azure services to your infrastructure. And the reason why you might want to use Azure Managed Services is because Microsoft takes care of everything. For example, if you install a SQL Server on-premise, you have to make sure that you have updates installed, you have backups, make sure of the resources, you need monitoring. So it can be quite time consuming, and you also have to have quite some skills. And if you use a managed instance, Microsoft takes care of everything. So you always have updates installed, Microsoft creates the backups, and also gives you a Kibana and Grafana instance. So you can see Kibana here. That's a dashboard where you can see all our logs. So out of the box, I can see already what's going on inside my SQL server. And the same with Grafana. Everything you can see on this dashboard comes out of the box. So I can see what's the CPU usage of my SQL server, how many transactions do I have. So it's a very good way to get started. And Grafana is a popular tool, so many. If I want to change something, it's a couple of clicks and I have a new dashboard. As I said before, you need Kubernetes to run the services. It runs in its own namespace, so it's separated from everything else, and you can again install it with the Azure CLI or the Azure portal. If you use the Azure CLI, it's quite simple. So what you do is you provide a name, a namespace, and that's basically it. And then it asks you for a username and a password to sign in. And then it takes around 10 minutes, and you have a full-fledged database running. The biggest advantage of this is, as said before, you are the owner of the data. It never leaves your on-premise. You know what's happening with it. And the only information that's sent to Azure is some metadata for billing. For example, how many CPU cores are you using and for how long is the service running? And I said before, for the first time, you can also use Azure App Services. Azure App Service is one of the oldest services in Azure and probably one of the most powerful and underrated ones because it's very simple to run APIs, websites, and so on. But it's very powerful. Like it has auto scaling, load balancing. Microsoft takes care of DNS management. You get an SL certificate. You can deploy directly from Visual Studio. So it's very easy to get going. And with this service, you can use it the same way as in the cloud, but just on-premise. So also Microsoft takes care of the DNS entries. You get an SL certificate if you want to have it public. You can have load balancing, so you don't have to manage anything. And the best thing about it, it's currently free. The reason why it's the case, it's still in preview. So there's no information about pricing right now. But along the time you can save with not having to set up a web server, configure it, and so on. It's probably worth it. And the way it works is you create a custom location, and then you deploy to this custom location. So since we're almost, we are already out of time, so I'm gonna quickly show you screenshots how this works. So the Azure portal, if you open the web service, you have to select a name, a resource group, so basic information, and then where you want to deploy it. For example, here you have a couple, Canada, you have the US, but once you have a custom location created, you can select this custom location. So in this case, it was running on a Raspberry Pi in my basement, so I called it Wolfgang Basement. And once you select this custom location, you can see there's no app service plan. The app service plan is used for billing. It gives you a certain amount of resources and then you pay for it monthly. But since I'm using my own infrastructure, I'm not using Azure resources, so I don't have to pay for it. And once it's deployed, I can see here on the left, I got the public URL. And I can configure a custom domain, SL certificates, I can scale. So everything quite easy and with just a button click. And if I click on the URL, I can see it's running on the internet. I have here a valid SL certificate and I can deploy my application there. Okay, and to round it up, our proof of concept was, in my opinion, very successful. We achieved everything we wanted to achieve. We had modern workflows, we had secure deployments, secure access, and it also showed Azure Arc is a very powerful service. And in my opinion, it's a major focus from Microsoft. So if you go to Ignite or any other Microsoft conference, you always hear something about Azure Arc to manage services. The downside is you have to have a lot of knowledge about many things. For example, Kubernetes is always the base of your services. So you have to know how Kubernetes works, how to access it. You have to know like firewalls, networking for deployments, and you have to know GitOps. It's not easy to get started. They can be quite buggy. For example, the Azure App Service extension is still preview, but it's sometimes unusable. And I was writing about it on my blog, and I had some reader text me if I could help them because it's not working for them, but it was just not working. And as said before, documentation really needs improvement and can be quite frustrating. And here I have a couple links for you. So the slides, they're on my GitHub, but I'm also gonna send them out on Twitter later. Then I'm currently working on an Azure Arc series on my blog and also on YouTube. I haven't done any work on it in the last couple of months because I just moved to Australia, so didn't have time. But starting in January, I plan to continue this and a couple more links. And that's it. So thanks, everyone. And if you have any more questions, I'm happy to answer.
Mute here. Thanks very much, Wolfgang. That was a really great glimpse at the future. You underscore how Arc is central and how Kubernetes is taking on an even larger role in probably more so in all of our futures. Does anybody on the call have any final questions for Wolfgang?
Yeah, I have a question. Wolfgang, this is a beautiful system. This was a prototype that you made?
This was a prototype. So I worked as an external contractor for this company because they needed help with the know-how and just get new ideas how I could work. And my contract expired after the proof of concept was done. So I can't tell if they implemented it or if they went another way. In my opinion, it would be a great solution, but it's their decision, so I can't tell. What I can tell you, I work for a different company. It's a company that builds machines, and they go the same route. So right now, I'm also building like a concept to bring the machines to the cloud, to have smart machines, and we also go with Azure Arc, because many of their customers are quite conservative. They say, we don't want the cloud, we don't want internet connections, we have to be highly secure. And with this approach, we don't have any connection inside the network. So they can manage the firewall and everything is secure, but you can still use Azure services. So we have the power of the cloud, but the security from on-premise.
Are those oftentimes when you deal with hardware, you have to have real-time systems? Is there a component to this? Because we never actually saw what the actual program, how it interacts. But is there a module of this that is real-time?
The machines are real-time, but the approach we go is that we have the machine with the real-time Linux version, and then in our Kubernetes cluster are services running, and the machines call the services. For example, what should I build next? What part? Or what is the configuration I should apply next? So our Kubernetes cluster is not real-time.
Oh, I see. Very nice.
Just a quick question. So is Azure Arc basically like an SSH agent that you just deploy in the on-premise systems?
It works with HTTPS, okay. But a bit simplified, yes. You have the Azure Arc agent inside the Kubernetes cluster, and then it just sends information about over HTTPS to Azure.
Okay. Thank you.
Okay, well, thank you again, Wolfgang. We'll leave you to go have breakfast, and thanks everybody for joining. This is our last session for 2022, and watch the usual spaces for announcements for 2023. Have a great holiday, everybody, and see you next year. Thanks again, Wolfgang.
Thank you for having me. See ya.
Great.